Hello, everybody. I hope that you're as excited as I am for this great hackathon weekend. So I'm Yanis. I'm part of a team called PSE, which is under the umbrella of Ethereum Foundation. And we are working on a protocol called Anon Aadhaar. So what's Anon Aadhaar? Anon Aadhaar is a zero-knowledge protocol that allows you any Indian citizens to prove their identity in a privacy-preserving way. So I'm going to go into details about what problem we are solving. So let's say that you're a citizen, you have an issuer, which is the government. In the case of Aadhaar, it's, for example, the DIA, which is the signer of your ID. So they give you your ID. So basically, okay, you have a number, you're a citizen or a resident in the case of Aadhaar. So the goal of it is like you need to give your information to a prover, and the goal for this prover is like to prove a verifier that you're a citizen without revealing any information about your who you are. So that's what we are achieving with Anon Aadhaar. So how does it work? So we are relying on the ETHIndia. It's also work on the masked ETHIndia. So we're in this PDF, you have a signature, and you have also the hash of the PDF. So we are just querying like these two informations, and with these two informations, we're gonna check this information. So what's happening? So you have in the PDF the hash of the PDF, which is the hash of all the contents of the PDF, and this hash is signed with RSA. So we are querying the information, the signature and the hash inside of the PDF. We are fetching the official RSA public key of the UIDI. And so we are going to verify the RSA signature. So RSA lets you like easily verify the signature. So what is the innovation here with Anon Aadhaar is that we are doing it like inside of a snark, resulting in a proof that this RSA verification was done in the proper way with some inputs, with secured inputs, and resulting in a proof of residency that does not reveal any information about you. So here is just the logic about the circuit and how it is the process of proving. So you have the RSA public key, which is public because we need it public because you can use the circuits to verify any RSA signature. So to verify that you are to acknowledge the fact that you prove UIDI document, we need their public key, and we need it to be public because anyone who's verifying your snark proof needs to see that you used the official public key as an input. As a private input, you have like the RSA signature. Also, the PDF hash is private here because we don't want to reveal any information about yourself. And you have an application ID. So we use the application ID and the PDF hash to hash it, and the output of the circuit is a nullifier. So the nullifier, you can see it as a unique ID. So let's say that you want to prevent someone like to double spend their proof into your apps. You can use the nullifier to nullify the user. So you can verify, for example, a proof in your front end. You query the nullifier, and you can send the nullifier to your backend or to your smart contract. And so this is the variable that you will need to nullify, because the nullifier is supposed to be the same for the same PDF. So we did all the complicated part. So now let's abstract a bit this complexity, and let's onboard you on how you can like use this primitive like into your apps during this weekend. So we built a SDK that lets you seamlessly like import what we did. So what you just have to do is like to generate an app ID. You can run this small script and take the output of this script. You just have to add our SDK and our provider alongside your app ID, and then you have like a hook and a connect component that you can use into your apps. So this is like you can do it like under 5 minutes, and you can add like a privacy layer onto your apps. You can build like Sybil resistance use cases, and you can build also like let's say that you want to build, I don't know, like Twitter just for Aadhaar residents. You can build it with it like very easily. So the SDK will serve you like these components. So this is the flow that you need to do. So you need to upload like your masked Aadhaar PDF, and you need to enter your Aadhaar PDF. So as I said, as I show you, so you have like the extraction part. So when you upload the PDF, we are going to search for the signature, and we are going to search for the hash. So that's what we are doing here. And the password help us like to first ensure that you are the owner of the PDF that you are uploading. And secondly, like we need it to query, like for example, a certificate. So the certificate is where like all the information about the signature process is stored. So just want to highlight here, so everything runs locally, meaning that in the process, nothing is shared to anybody about the Aadhaar PDF. It's just that everything runs in the browser within the SDK. So you don't need to send any information to your backends, any information to the chain, whatever. You just need to use the SDK. The user upload their documents, and they can like locally prove their identity, resulting in a PCD proof. I will talk more about PCD after that. And so you can use this proof to authenticate a user, to nullify their interaction and stuff. So everything is handled by the SDK actually. Just want to highlight that what ensure here privacy and data security is that everything happen like locally on the browser. Yes. So in the documentation, you will see that you can download like a test PDF. So this PDF is like a fake PDF that is emulating the specification of the ETHIndia PDF. So it has like a RSA signature, and you can use it like for developments. In the case like so, by default, the SDK will be able like to verify both the test file and both your real masked Aadhaar, if you want to test with your real masked Aadhaar. Why? Because by default, it will just verify the RSS signature. And as the fake document and the real document have real signature, as I said earlier, what we need to ensure that it is like really like ETHIndia that we are verifying is by inputting the official public key. So in the SDK, you have a mode. You have a testing mode, and so if you want like to, for example, like to generate a real proof of your real ETHIndia and a proof with the following statement, I have like a document that is signed. I have an ETHIndia that is signed by the UIDI. So in this case, you can put the testing mode to false, and you will be able like to generate a real proof of your ETHIndia. But yeah, you still have like a testing mode. You can use like the signed PDF and the password if you don't feel comfortable like developing with your real Aadhaar. It's not something that we will require you to do like even if you're in your video demo, like you're using like the test PDF, the signed PDF. It's completely okay. We understand that it can be like quite sensitive, like to upload your ETHIndia, so it's up to you. So let's talk about the proof format. So in the SDK, when you will generate a proof, you will authenticate the user, and this proof will be written into your browser. So what's in there? So you have a type, which is the name of our PCD, the Anon Aadhaar PCD. You have an ID. Just want to highlight here, this ID should not be used. It's like just a random UU ID. Don't do anything with it. It's like just dumb data. You have a claim. so what is the modulus? The modulus is the public key. So again, you can always verify that someone generated a real proof by querying the modulus inside storage inside of the proof. And you have also the nullifier. So as I said, the nullifier should be the variable that you need to use in order to nullify any interaction. Let's say that you want to create a voting platform on chain or off chain. You can use the nullifier to say, okay, so this is a unique user, and assign a boolean to this nullifier and say, okay, true, false. Does he voted? Yes, no. And then you have the proof, which is a gross 16 proof. You have also the app ID, which is the app ID that is the input of the circuit. Okay, so the SDK also provide a solidity verifier. So what you will find in the package Anon Aadhaar contracts is just a basic gross 16 verifier. But to verify proofs on chain, you need to add some more logics. For example, as I said, you need to check the modulus, for example, and plus you need to ensure some cryptographic tricks that can be done over verifying snark proofs on Solidity. So that's why, so at the end, I will give you the QR code of the GitHub repo. Inside of this repo, you will have a link to the example app. In this example app, you have all the contracts, an implementation on how you should verify proof on chain. You can follow this app, Anon Aadhaar example, or copy paste the contracts and the configurations that are there. Yeah. So just want to highlight, yeah. So don't just use the verifier. Check also this example, because it have some security layer that you will need to check proofs on chain. So let's talk about what you can do this weekend with Anon Aadhaar. So Anon Aadhaar can be used mainly if you want Sybil resistant use cases, if you want use cases that are that you want to enable only for Aadhaar residents, and it can also be used for anonymous KYC or proof of humanity. You want your users to prove that they are human, so you can basically verify their Aadhaar with Anon Aadhaar, and you will ensure that they are an Aadhaar resident and a human. Yeah. So the prizes. So we have 3 tracks. We have the main track, which will be all the application that integrates the Anon Aadhaar SDK can apply to this track. So the judging criteria will be the technical implementation. We are going to check if you really use the SDK into your app. Also does it solve a problem into your app? And also in terms of UX, and the flow of your application and the problem that it solves. I'm just heading to the last one. Best social goods build with Anon Aadhaar. So this this track is we are going to judge, of course, the technical implementation and if Anon Aadhaar solve a problem in your application. But we mostly want to highlight the project that have the most potential social impact. And so the best implementation of Anon Aadhaar on mobile. So that's a bit a special prize, because at first we thought about it because for now you can only verify you can only have the proving flow on web application. So our circuits are built with Circom, and so the backend is gross 16. But you have some way to compile the files needed to compute the proof, so they can run natively on mobile. So you have 2 solutions to do that. You can use a project called MoPro, or you can use Rapid Snark, which is a compiler developed by Ethereum. So this is a bit more technical, and this is a bit more low level. But just want to highlight here that of course, like if we have a team that achieve like a real mobile proving by compiling the circuits for mobile, there will be, it's gonna be crazy and super cool. Just want to highlight that if we don't have a team that achieve to do that, we will still reward like the best implementation that runs on mobile. So it can be like, for example, a progressive web application. So it's gonna be browser proving in browser. But yeah, just want to highlight here that it's okay. It's okay if you want like to don't have like all the hassle of doing pretty low level stuff. You can still build it this way. And yeah, so that's the link to the GitHub repo. Don't hesitate to pass by our booth to ask all your questions.